Good day, everyone. Welcome to my YouTube channel. In today's class, I'll be explaining an important topic in mathematics, which is binomial theorem. Binomial theorem. So you might be wondering why I am teaching this. I'm teaching this because there are some hidden concepts under this particular topic that many students find hard to comprehend. And in today's lecture, I would be doing my possible best to uncover those hidden concepts. Let's start with binomial. What is binomial? Actually, binomial is a type of polynomials. You might be wondering, what is a polynomial? Polynomial. Okay, let's make it this way. Polynomial is actually gotten from poly and nomial. Yes, polynomial is gotten from these two words, poly and nomial. Poly simply means many. Nomial simply means terms. So therefore we say polynomial is an expression, an algebraic expression with many terms. So it is from polynomial we got binomial. Binomial is a type of polynomial with two terms. When I say two terms, binomial, also the word binomial is gotten from bi, which means two. Of course, when you hear bi, it simply means two. And when you hear nomial, it simply means terms. So therefore we say binomial is an algebraic expression with two terms. Or you could say binomial is a type of polynomial with two terms. I hope this is clear. Now let us quickly deal with this word, terms. What is a term? A term could actually be a number, your 1, 2, 3, 4, 5. They are all terms. This is a term, single terms. Do you understand? Same. So a term could also be a letter. Your A could be a term. Your B could be a term. C, a term. D, and so on. In fact, a term could also be combinations of letters and numbers. Let's take, for example, 2a is a term, just a term. I mean one term. 13z is a term. 50b is a term. Okay? So, if you want to have two or more terms, then you need to introduce your addition and subtraction. That is, when you have, let's take for example, you have 1 plus a. Of course, like I said, 1 is a term, a is a term. Do you understand? 1 is a term, a is a term. What binds both together? Our plus sign, right? Yes. So, this here is two terms. These are two terms here. And we call it binomial. Okay? In a situation whereby you have two terms, we call that expression binomial expression. So I want to believe this is clear to you. Okay, let's get this off. So when I say binomial, you should remember that binomial is an expression with how many terms? Two terms. And how do we separate terms? We separate terms using our plus and minus sign. If you have a minus b, we have two terms here. Yes, the two terms are being separated by the minus sign. But if you have a b, this is just a single term. What is binding a and b together? It is times. That is binding a and b together. Like I said, it is only plus and minus that can separate terms. When you have times in between like this, no, we call this a single term, just one term. So I want to believe that's clear. Okay, now let's come to our binomial. So before I go further, I would love to introduce us to three things. Yes, these are the main thing we'll be doing under binomial theorem today. And the first thing is our normal expansion. Yes, everyone, right from the primary level to secondary level, and has done this. So normal expansion. What is the normal expansion? Let's take, for example, if you are told to find the expansion of 1 plus x squared, what do? We write 1 plus x in two places, right? We say 1 plus x in a bracket, another 1 plus x again in two places because of the power 2. Yeah. So how do we expand this? Whenever you have two or more brackets like this, we have two brackets here. The first bracket, we have 1 plus x. The second bracket, we have 1 plus x again. Let's assume you have more and more brackets. If you want to expand that, you need to take them in pairs. That is, in two. You pick these two together, multiply out first. Do you understand? After multiplying these two, what do you do next? Whatsoever you get, take it together with the next bracket, multiply out again, take it together with the next bracket, multiply out till you are done with your expansion. So let me show you how to expand this. The first thing you need to do here is look at the first bracket. Do you understand? How many terms do we have in the first bracket? We have two terms. That's 1 and also plus x. 1 and plus x. These are the two things we have in the first bracket. You'll be using the 1 and the plus x to times the second bracket. So this is what you do. 1, then you put your second bracket here like this. Also, you pick the plus s in the first bracket again like this. Use it to times the second bracket again. Simple. So what do we do next? We say 1 times 1, that's 1. 1 times x, that's x. Easy, right? X times 1, that's x. X times x. Now, whenever you are multiplying letters, you add their powers. Whenever you are multiplying same letters like this, you add their powers. If they are different letters, you bring them together. Let's say, for example, you have a times b. A times b is going to give you ab. But if you have a times a, what do? You add their powers together. This has a power of 1, so that will give you a squared. So that's cool. Now, s times x would give us x squared. Now, what do you notice here? We have what we call like terms. Like terms are those letters with the same power. What am I trying to say? Look at this x here, it has a power of 1. Look at this x here, it has a power of 1. So they are like terms. In a situation whereby you have like terms like this, you combine them, make them single. So what do we do here? 1 plus x plus s. This is just a single s plus another single s. That would give you 2x plus s squared. That's all. You can rearrange, write in descending order from the highest power, come to 2x, and you're 1, and you're done. That's all. So this is how to expand your binomial. This is a binomial, this is a binomial. Pick the first thing you have here, use it to multiply like this. Pick the second thing, use it to multiply also, and finish your expansion. Find the like terms, and you're good to go. Okay, so that is what we call normal expansion. Okay, we got this now. I won't rub this off. We might need this. Okay, let me quickly show you something very important. Another important part. Okay, let's do it this way. What if you are told to find the expansion of 1 plus x raised to the power of 3? What do? Here we have 1 plus x in 3 places. 1 plus x and 1 plus x. If it is raised to the power of 10, that means you'll be having 10 brackets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you understand? So, but now we have just raised to the power of 3. So we'll be having 3 brackets like this. So what do? Like I said earlier, you pick them in 2. You multiply these 2 first. Whatsoever you get, take it together with this third one, multiply out. But fortunately for us, we have multiplied these 2. That gave us this x squared plus 2x plus 1. So what we just need to do is pick this, use it to multiply the third, and we get our answer. So I'll be having, let me have my 1 plus x. The third one, this is it here. So I'll be having my x squared plus 2x plus 1. Now, so what do I do now? You pick the first term according to my explanation. Pick this one, use it to multiply this. That's x squared plus 2x plus 1. Then pick this plus s also. You pick it with the sign. This one, the sign is positive. We don't need to start putting plus. Okay? I mean, this one here, the sign is positive already. You know, this is the one here. This second bracket, this is it here. So I'm going to pick my plus x now. Use it to times the second bracket again. That's x squared plus 2x plus 1. Can you see this? Okay, good. So what do we do next? 1 times x squared, that would give x squared. 1 times 2x, 2x. 1 times 1, 1. Plus s times x squared. I told you, when you have same letters multiplying, you add their powers. S times s squared. This one has a power of 1 outside there. This one has a power of 2. That would give us a power of 3. That's s cubed. Plus x times 2x. That would give us 2x squared. Don't tamper with 2. X times x. That's x squared. Plus x times 1. That would give us just x. Yeah, that would give us just x. So what do we do next? Let's check if we have like terms. If we do, let's combine them, make them single. But if we don't, that means we don't have to do anything. Okay, x squared, s squared. Wow, like terms. This one is just 1x here. This one is just 1x. Why this one is just, this one is 1x squared. This one is 2x squared. When you combine 1x squared and 2x squared together, that would give 3x squared. Why are we combining? We are combining because of this plus sign. You know, s squared plus 2s squared. Actually, this 2s squared, the sign is this plus you are seeing here. This s cubed, the sign is this plus you're seeing here. This one, the sign is this plus, and so on. So s squared plus 2x squared, that will give us 3s squared. Okay, 2x, do we have any other x? Yes, we have another x here. 2x plus x, that gives 3x. Okay, let's go. Oh, we have s cubed. Do we have any other s cube? No. Let's put our s cube down. And 1. We don't have any other number. That's our answer. Simple as ABC. This is still what we call normal expansion. Now, let me quickly show you something surprising. I'll show you something surprising now. I'll show you something surprising. If I tell you to find 1 plus x to the power of 30. Wow. I know you might be shocked. The power is huge, right? It's large. Yes. Now, using normal expansion, that means we need to have 1 plus x times 1 plus x times 1 plus x times, in fact, that would be too much. Oh my God. Oh my God. Oh my God. 1 plus x, 1 plus x, Jesus, this is too much. This is choking. In fact, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I only wrote 10 out. I've not even gotten to 20, and I'm still going to 30. I'm still going to 30. Can you imagine? We have just 10 here, and we're still going to 30. So that means normal expansion, in fact, it would make this thing complicated. Yes, it will be too complex. Actually, it is possible, but you know, you have to multiply this into it will take the whole. In fact, this might take you, a week before you finish, and we don't have time to spend. So what do we do if we are given something like this? In fact, if it was just one, if I give just 6, normal expansion is still going to be difficult. If I give to the power of 6, it's still going to be large. 1, 2, 3, 4. We have to multiply these two out first. Whatsoever we get, use it to multiply the third. Whatsoever we get, use it to multiply the fourth. Use it to multiply the fifth and sixth. That's going to take our time also. So what do we do here? What do we do here? What do we do? That would bring us into a new concept called, like I told you, we have so many concepts under this binomial theorem. That will bring us to a new concept called binomial expansion. Yes. What is binomial expansion? Binomial expansion is just another method, okay? Yes, another concept that we can use to find our binomial expansion. Do you understand? To expand our binomial expression, okay? Yes, just the way we have our normal expansion, we have our binomial expansion too. Now, what is this binomial? All right, so what is binomial expansion all about? Before I take any step further, I want you to understand something. Whenever you are working with binomial expansion, always remember this. What's this? Pascal triangle. Pascal triangle. Pascal triangle. What is Pascal triangle? Pascal triangle is just a series. It's just a series of numbers written or that is constructed in a triangular form. And I'm going to teach you how to construct your Pascal triangle right now. The first thing you need to do whenever you want to construct your Pascal triangle is start with 1. In fact, you will always start with 1 and you will end with 1. Do you understand? Start with 1, end with 1. So, you start with 1. The next line, you go again with 1, 1. Yes, you always start with 1 and end with 1. That's how it works. You go again, 1, 1. But this time around, you will add the numbers above. Whatsoever you get, put it at the center. 1 plus 1 above gives 2. This is what we call Pascal triangle. I'm not done. You go again. 1 plus 2 here gives 3. 2 plus 1 here gives 3. And end it with 1 again. Let's go again. 1 plus 3 here gives 4. 3 plus 3 gives 6. 3 plus 1 gives 4. And 1 again. Can you see the shape? It is taking the shape of what? A triangle. And that's why we call it Pascal triangle. Let's go again. 1 plus 4, 5. 4 plus 6, 10. Make sure you are writing at the middle, center. 6 plus 4, 10. 4 plus 1, 5. And 1. In fact, you can keep going till I don't know. Let's go one more. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. And 1. You can go to 7, you can go to 8, 9, 10, 11, 12. That's Pascal triangle for you. Now, all these numbers you're seeing here, they are called binomial coefficients. Binomial coefficients. Yes. So, binomial coefficient is actually needed whenever you are carrying out your binomial expansion. Whenever you are using your binomial expansion method, you always make use of your binomial coefficient. These numbers here, like I said, they are your binomial coefficients. Don't worry, when I give you a sample, I will show you how to pick out your binomial coefficients from your Pascal triangle. Okay, let's go. Okay, so now I'll be giving you an example so that we can apply binomial expansion. Yes, and I'll be giving us same sample. All right, so let's see this sample together. We have, okay, it says find okay, let's make it determine. Let me make it determine using Pascal triangle. Determine using Pascal triangle method. Immediately I mentioned Pascal triangle method, you should know what we are dealing with. Pascal triangle method, the expansion of, now let's see it, expansion of what? 2p minus 3q raised to the power of 5. Determine using Pascal triangle method the expansion of this. How do we determine? Very easy. The first thing you need to do here is follow this principle. Follow this. We have two terms as usual. 2p is a term, minus 3q is a term. Can you see? I mentioned 3q with its sign, minus. You know, 2p has a plus sign. Yes, it's positive. 3q has a negative sign. So 2p is the first term, minus 3q is the second term. Now, you look at this. You write 2p in a bracket raised to the power of 5. Your first term will always carry your power. This is Pascal triangle method. This is the binomial expansion. This is not normal expansion, okay? This is binomial expansion. Now, 2p, your first term will always carry your power. So, since 2p is our first term here, it will carry the power of 5. Now, what will happen to our second term? See what will happen. Our second term will carry a power of 0. Yes, it has a power of 0. Do you understand? That is how it works. Plus, you'll keep adding. Let's go again. 2p. Now, something will happen here. And that thing is, 2p has a power of 5 here. The power of our first term will reduce to 4. That is, you subtract 1 away from 5. That gives 4. But something special will also happen to this, our second term. Watch. Minus 3q will have a power of 1. A power of 1. The power was 0 here. It increased to 1 here. Yes, that is how it works. Let's go again. Plus 2p raised to the power of 3. You subtract 1 from this 4, it becomes 3. You keep reducing the power by 1. Your second term will increase again. To what? 2. Plus, let's go again. 2p, 2, subtract 1 from 3, becomes 2. Then open another bracket. Your second term will become 3. Let's go again. Plus 2p raised to the power of 1. Then minus 3q raised to the power of 4. We are not done. Plus 2p raised to the power of 0. And finally, minus 3q raised to the power of 5. This is binomial expansion. Yes. The power of your first term. Okay, the first thing I said was your first term will carry the power you have, while your second term will carry a power of 0. But then along the line, the power of your first term, as it is reducing, the power of your second term will be increasing. That is purely binomial expansion. The power of your first term will be reducing. The power of your second term will be increasing. You see, it was 0 here. 1, 2, 3, 4, and finally 5. This one, which was 5 here, 4, 3, 2, 1, and 0. Simple. So let's simplify the whole work. Now let's go. Let's break our work down. 2p raised to the power of 5. 2 raised to the power of 5 is 32. P raised to the power of 5 is p raised to the power of 5. Of course, whenever you have anything in your brackets like this and you have a power out there, the power is for everything in your bracket. This 5 out here is for 2 and also for p, not only for p. That is why it is wrong to write 2p raised to the power of 5. Better you write it in a bracket. Okay, so 2p raised to the power of 5. 2 raised to the power of 5 is 32. So we have 32p raised to the power of 5. Oh, minus 3q raised to the power of 0. Obviously is 1. Okay, so let's come here plus. Now 2p raised to the power of 4. 2 raised to the power of 4 is 16. That's 16p. This will be 16p. 16p. Oh, we still have a bracket. Let's put it there. Minus 3q. Okay. Plus 2p raised to the power of 3. That's 8p raised to the power of 3. Okay. Let's come to the next line. Let's come to the next line here. 8p raised to the power of 3. And now minus 3q raised to the power of 2. That's minus 3q like this times minus 3q. Minus times minus is plus. 3 times 3 is 9. Q times q is q squared. So 9q squared. That's what we have. So we have 9q. Oh, sorry. 9q squared in the bracket. 9q squared. The square is only for q. Square is only for q. Don't put the square again on 9. That would be wrong. Okay, so let's come to the next. 2p raised to the power of 2. That's 4p. We have plus 4p. Now minus 3q raised to the power of 3. That'll give us minus 27q raised to the power of 3. Yes, minus 27q raised to the power of 3. Okay, let's come to the next one. Plus, now 2p raised to the power of 1 is still 2p, of course. We have this here, minus 3q raised to the power of 4. That's 81q. Yes, 81q. Okay, what next? This next. This raised to the power of 0 is 1. Then we have this would be minus 243q raised to the power of 5. We are almost done. We're almost done. So next thing here is let's simplify the work. 32p raised to the power of 5 plus, okay, no, not going to be plus. We have a minus here, so that'll be minus 16 times 3 is 48 p q. Yeah, actually I skipped something here. I was meant to have p raised to the power of 4 here. Yes, I'm just gonna put it p raised to the power of 4 there. So yeah, I'm supposed to have p raised to the power of 4q. Okay, let's go. Plus 8 times 9 72 p cube q square. Okay, that's it. Okay, let's go again. Plus times minus is minus. 4 times 27. Okay, let's make use of our calculator. So let's make use of our calculator here. 4 times 27, that's 108. Okay, so we have 108p, just p, and q raised to the power of 3. Okay, let's go again. Plus 2 times 81, that's 162 p q. Okay, plus times minus is minus, obviously. 243 q5. Are we done? No, we are not done. We only simplified the whole work, and I'm sure this is too easy, in fact, for a primary school kid to work on. 32p5, 16p raised to the power 4, just multiply out. If you can use your calculator, if you have problem with your multiplication, 16 times 3, 48 and so on. Okay, so we are not done. Don't forget this, your Pascal triangle. I mentioned this. I said your Pascal triangle, you need to go get your binomial coefficient from your Pascal triangle. So yeah, we are not done with our, we have actually expanded, but we need to add our ingredient, which is our binomial coefficient. Now, how do we pick binomial coefficient? Now, if you remember, the main question we are solving is 2p minus 3q raised to the power of 5. That's the main question we are solving. What's the power there? 5. So you need to go to the 5th level. Since the power is 5, you go to the 5th level on your Pascal triangle to pick your binomial coefficient. I know somebody is confused. Now, let me show you the first level. This is your first level. You have 1. Sorry, this is your 0th level. I call it 0th level. Okay, let me just use a pen here. I call this 0th level. Yeah, I call this 0th level. I call this 0th level. 0th level. I call this first level. I call this second level, and so on. Third level, but always start from 0th level. Do you understand? So now, where is our 5th level here? This is our 5th level. This 1, 5, 10, 10, 5, 1 is our 5th level. So we'll be picking 1, 5, 10, 10, 5, 1 now. We'll be picking 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. That's what we'll be distributing over these terms here. This first term we carry the 1. This one we carry the 5. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10. So what would that be? So 1 times 32. Okay, let me just make it easy for you. Let me write the 1, 5, 10, 10, 5, 1 here, so you can see it with your 2 eyes. 1, 5, 10, 10, 5, 1. So use your 1 to multiply the first term. 1 times 32 is 30. That's 32 p raised to the power 5. We are done with that. Minus 5, use it to multiply the second. 5 times 48 is, can you see, 240. 5 times this 48, that's 240. 240 p raised to the power of 4 q. Come again, plus 10 times 72, that's 720 what? 720 p raised to the power of 3. P raised to the power of 3 q squared. Let me put it here so you can see. Yes. 10 times 108. That's 1080 p q raised to the power of 3. Now 5 times 162 here. 5 times 162 gives 810. 810. That's plus 810 pq. PQ. And lastly, 1 times 243, that's 243 q5. And we are done. This is the real expansion. Yes. So the main question, which is expand using Pascal triangle method, 2p minus 3q raised to the power of 5. This is our final answer. So what was the first thing I did? I picked my first term. My first term carried the power. My second term carried a power of 0. Now, the power of my first term keeps decreasing. The power of my second term keeps increasing. And after doing that, I went to my Pascal triangle to pick my binomial coefficient, and I added my binomial coefficient, and that's all. Simple. Just 2 steps. Expand it first. After expanding, go to your Pascal triangle, pick your binomial coefficient, and distribute it on each terms, and you are done. This is what binomial expansion says. Very easy compared to normal expansion. In fact, if it were to be normal expansion, we are done. Trust me, this won't even occupy at all. Yes, and we can't be done by now. Okay, so that's just the advantage of binomial expansion. Now let's go forward. Now, just the way normal expansion could not go far, could not take us far, binomial expansion also can't take us far. You know why? You know why? Let me show you something. If you have 1 plus x raised to the power of, let's say, 15. Yes. Just 15. Please, look at this. How long are we going to keep drawing this? 1, 7, you know? This is just 1, 7. I still need to do 1, 8, 28, 56, and so on. 1, 9, 1, 10, 1, 11, 1, 12, 1, 13, 1, 14, 1, 15. In fact, that would be too long also. Or what if we are given raised to the power of 20? That would still be too long. We can't keep drawing our Pascal triangle up to that length. It is too long. Yes. So what do we do in that case? We still need something, a ransom. We need something that can save us from this stress. And what is it? That would bring us to the final stage of this topic, which is, that would bring us to what we call binomial series, or theorem. Yes, binomial series or theorem. This is the master of all, can solve any kind. Now, I forgot to mention, our Pascal triangle contains only positive integers. Positive integers. Don't forget 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on. Do we have any negative integers? No. Do we have any fraction here? No. But what if you are given something like this? Raised to the power of -5. Don't forget that when we wanted to pick our binomial coefficient the other time from this, we had to use the power given in the question. We were given a power of 5. You can rewind the video back to confirm that. We're given a power of 5 in the question. And it is that power of 5 that made us go to the 5th level. Yeah. That means it is our power that helps us determine the binomial coefficient on Pascal triangle. Okay. So what if we have raised to the power of -5 here? How will -5 help us determine our binomial coefficient? Do we have anything like -5th level on our Pascal triangle? No, I never mentioned that. We don't have anything like -5th level. They are all positive numbers. So binomial expansion can never solve this. Yes, it can't. Or you can even have something like 1/2. In this case, it still cannot solve it. So with the help of our binomial series, we will be able to solve more and more questions that comes in this kind. So let's go. Now, binomial series. What does binomial theorem state? If you are given a binomial expression like this, a plus b raised to the power of n, where your n could be positive integer, your n could be a negative integer, your n could be a fraction. How do you what does binomial theorem state? It says this is how you apply binomial theorem. If your n is positive or negative or even a fraction, you don't mind, you don't care. All you need to do is your first term, which is a here, will carry the power as usual. So that will be a raised to the power of n, while your second term will carry a power of 0 as usual. It looks like the binomial expansion, right? Yes, it does, but it is not binomial expansion. This is binomial series. Now you have divided by 0 factorial. Yes. You write plus, you add, you keep adding. Now, what will happen next? Your n here will come to the back. Okay? Once you move your n to the back, you subtract 1 from the power. So you have something like n a, then you have n minus 1. You subtract. Once you go to the back, you always remember to subtract 1. If you don't subtract 1, then you are no more doing binomial series. You are doing something else. Okay? So b raised to the power of 1. B was raised to the power of 0 here. The power increased to 1. You had 1 to it. Okay? Divided by, what's the power of b here? 1. So you have 1 factorial. That's the next thing. Okay? Plus, you keep doing same thing. N minus 1 again would come to the back. You know, you have n there already at the back. So n minus 1 will come to the back. You put it in a bracket like this. N minus 1. So what will happen again? You have a raised to the power of n minus 2. Subtracted 1 again from it. That gives us n minus 2. Then your b would be raised to the power of 2. This time over 2 factorial. And so on. Plus, and so on. Yes. This is what we call binomial series. Or you can call it binomial theorem. Easy. So this is the method we'll be applying to every questions now. So I'll be giving us a sample. Expand c minus 1 over c raised to the power of 5 using binomial series. That's our question, our example here. So how do we solve this? Just follow the principle above. Your first term will carry your power. Second term will carry a power of 0, right? Divided by 0 factorial. Plus, the power will come to the back. After coming to the back, you subtract 1 from it. And the power of your second term will increase. Do you understand? Okay, so here we have what? Solution. Okay, so we have, let's start with c raised to the power of 5. Now, what's the second term? The second term here is minus 1 over c. Minus 1 over c. Always pick the sign with it. So you have c into bracket minus 1 over c. Your second term will be raised to the power of 0 as usual. Then divided by what? 0 factorial. Let's keep moving. Plus 5 will come to the back. Don't just subtract 1 from 5. No, make sure your 5 comes to the back. This is binomial series for you. Okay? Four. Can you say it? Minus 1 over c raised to the power of 1 this time over 1 factorial plus 5 times 4. You know, our 4 will surely come to the back. So you have c raised to the power of 3 minus 1 over c 2 over 2 factorial. Same thing. You keep going. 5 times 4 times 3 c raised to the power of 2. Oh my god. Okay, let's just cancel this place so we can be able to write it well. Let's come here. 5 times 4 times 3 c raised to the power of 2 minus 1 over c raised to the power of 3 over 3 factorial. Okay, 5 times 4 times 3 times 2 c raised to the power of 1 minus 1 over c raised to the power of 4 over 4 factorial. And finally, plus 5 4 times 3 times 2 times 1 c raised to the power of 0 minus 1 over c raised to the power of 5 factorial. We are almost done. Looking easy, right? Yes, that is binomial expansion for you. Okay, so what do we do next? Let's simplify the work. This 1 raised to the power of 0 is 1. Also 0 factorial is 1. So 1 1. So we'll be left with just c raised to the power of 5 here. Yes. Let's go to the next. 1 factorial here is just 1. 5. Okay. Now we won't write plus. Plus times minus here is what? Minus, of course. Then we have 5. In fact, c can cancel c here. So we'll be left with c raised to the power of 3 here. So that's 5c raised to the power of 3. We are done. Let's move to the next. 2 factorial is 2 times 1, which is still 2. And 2 can break this 4. We'll be left with just 2 here. 5 times 2 is what? 10. So we have 10. We have plus 10. Why did I write plus here? This is plus here, right? Also, we have minus here. But there is a square here. So minus times minus is going to be plus. So that is why I wrote my plus here. I have checked it already. Okay. See, this e here, due to the square here, this one too will be c square. If c square cancels c raised to the power of 3, we'll be left with just c. Good, right? Yes. Let's come to the next one. 3 factorial is 3 times 2 times 1, which is 6. So, okay. 3 factorial, like I said, is 6. So, 5 times 4, 20. 20 times 3, 60. 60 divided by this 6 here. You know, this is 6 here. 60 divided by 6 is 10. So, we still have 10 here. Let's put 10 here. I don't know. Is it going to be plus or minus? It is going to be minus. Because when you have minus raised to the power of 3, it's going to still give you minus. You can check it out. Minus times minus times minus is still minus. Okay, so 60 divided by 6. Okay, we got 10 already. Here, we have c raised to the power of 3 because of this 3 here. C raised to the power of 3 is here. C square can cancel c raised to the power of 3. You'll be left with c raised to the power of 3 under. You'll be left with just c under. You know, when you have c square, breaking c raised to, let me show you. When you have c square over c3, that is what we have here. You know, c square is on the numerator here, while c3 is on the denominator. Can cancel, you'll be left with just 1 over c. So that's why our c is under here, under the 10 here. So we are done. Let's come to this second to the last. It's going to be plus. 5 times 4 factorial is 4 times 3 times 2 times 1. And that can cancel this. So we have 5 here. Let's put our 5. C is here. But we have c raised to the power of 4 here, under. So it's just like having c over c raised to the power of 4. You'll be left with just 1 over c raised to the power of 3. So what do we have here? We have over c raised to the power of 3. Okay, let's come to the last. Minus. You know why I said minus? Because minus raised to the power of odd number is still going to give you minus. Here, minus raised to the power of even number is plus. That's why I wrote plus. Minus raised to the power of odd number here is minus. That's why minus is here. Get that right now. Okay, so we'll come to the last one. C raised to the power of 0 is 1 already. And 5 factorial, this is 5 factorial also. Because 5 times 3 times 2 times 1 is also 5 factorial. So they can cancel each other. This one is 1. So we are left with what? We are left with just 1 over c raised to the power of 5. This is our final answer. Our final answer. Final answer. Yeah. This is how to apply our binomial series. If it were to be binomial expansion, oh my god, this would have been more complicated. Yes, because we still need to go to our Pascal triangle to get our binomial coefficient. We need to put our binomial coefficient. Here, you don't need to add any binomial coefficient. Once you get to this level, you are done. You are correct. Easy. Okay, so that is all on binomial theorem. Don't forget, Your first time we pick your power. Your second time we get a power of 0 divided by 0 factorial. Don't forget your factorial under. Then your power will come to the back, subtract 1 from it, come to the back, subtract 1 from it, come to the back, subtract till you're done. Okay, so I would be taking another concept now, which is rth term of a binomial expansion. Rth term of a binomial expansion. Rth term of a binomial expansion. What does this mean? It simply means a particular term of a binomial expansion. I'm going to make reference to the last question we solved. Look at this binomial expansion here. Yes, you might be told to find the fourth term of this binomial expansion. Where's the fourth term here? This is the first, second, third, fourth. Yes, this is the fourth term. I'm going to write it out. Fourth term of this expansion is 5 times 4 times 3 c square minus 1 over c raised to the power of 3 over 3 factorial. 3 factorial is 3 times 2 times 1. This is the fourth term. All you just need to do is, after finding your expansion, go to the fourth term, bring it out. If you are told to find the fourth term, if they say find the fifth term of this expansion, you pick only this one out. If they say find the sixth term of this expansion, you pick this one out, and you're done. So since I want to teach you how to find the fourth term, bring the fourth term out and simplify. 3 can break this, 2 can break 4. You'll be left with 2. 5 times 2 is 10. So you have 10, c square times minus 1 raised to the power of 3 is still minus 1. I said this earlier. When you have minus 1 raised to the power of odd number, you get minus 1 over c raised to the power of 3. Of course, c square can cancel c raised to the power of 3. So you'll be left with 10 times minus 1 is minus 10 over c. This is our fourth term. Fourth term. Yes. So, but now, I want to show you something special. Special in what way? You don't need to carry out the full expansion of your binomial before you can get a particular term. You see, here, when we wanted to get the fourth term, we need to show the expansion. Then, after finding the whole expansion, then we need to bring out the fourth term. But how about getting the fourth term directly without even going through all this stress? That is why I want to teach you the rth term of a binomial expansion. Rth term, there is a direct formula I will be giving now. So I would want you to memorize, and I will teach you how to apply the formula to a problem. In fact, this same problem. Let's go. This is the rth term. To find the rth term of a binomial, if you are given a binomial, oh my god, okay, if you're given a binomial a plus b raised to the power of n, we say n combination r minus 1 a raised to the power of n minus r minus 1 b raised to the power of r minus 1. Simple. Like, just too simple. This is the strong man here. Yes, you can apply this instead of finding the whole expansion of a binomial before you can now bring that term out. You don't need to do that. You just apply this formula and you will get the term directly. This would help you when you are taking any exam, especially CBT exam. Okay, so how do we apply this? We'll be applying this to this same question now. Let's use this same formula to find the fourth term of this question. So we have c minus 1 over c raised to the power of 5. So how do we find the fourth term? Okay, firstly, let me break this formula down for you. N here stands for the power. R stands for the term you are looking for. Do you understand? A stands for the first term, B stands for the second term, and that's all. So here in this question, we want to find the fourth term of this binomial. So we need our A. Our A is this first term, which is C. Our B is minus 1 over c, which is our second term. R is 4, which they want us to find. Fourth term, okay? Your R is 4. If R is 4, R minus 1 will be what? 3, because 4 minus 1 is 3. N is 5. Yeah. What else do we need? Nothing. So let's plug the whole thing here into our formula. So that's 5 combination 3 c raised to the power of 5 minus 3. What's my B? Minus 1 over c raised to the power of 3. 5 combination 3. 5 combination 3 gave me 10. So I'm going to add my 10 here. C 5 minus 3 is 2. Minus 1 raised to the power of 3 is minus 1. I said this before. Over C3. This can cancel this. 10 times minus 1 minus 10 over C. Now tell me, what do you see here? Are they not the same? Yeah, we have to expand this whole thing. We have to bring our fourth term out before we can get minus 10 over C. But yeah, in just how many lines? Just 1, 2, 3, 4. 4 lines. We've gotten our minus 10 over C. Can you see how special this formula is? So don't forget, this is the rth term of any binomial expansion. How to find the rth term of any binomial expansion. Okay, so I'll be showing us the last concept on binomial theorem, and we are done. So I want to quickly show how to solve this, and that will be the last thing. Expand. We have a question here. That will be the last question for now, for this session. We have a question here that says expand 1 over square root of 1 minus 2t in ascending powers of t as far as the term in t cube using the binomial theorem. Yes, we want to. In fact, if you didn't see using the binomial theorem, you should know that you must use binomial theorem, because it is only binomial theorem that can work for this expansion. And I'm going to show you. Whenever you are given anything like this, try to make it linear. Make it linear. And how can you make this? Is actually a fraction, right? So let's make a linear solution. That's the first thing. Make it linear. Anytime you're given a fraction, make it linear. So let's start with 1 over. Now, square root can be written as 1 minus 2t raised to the power of 1 over 2. Our square root can be changed to an index form like this. Yes. And also, according to the law of indices, this can be 2t 1 over 2. Your 1 over here will become minus. That's the rule of indices. Okay, so from here, it's now linear, right? It looks like the usual binomial questions we have been solving since. Okay, so this is our first term, 1. This is our second term, minus 2t. And this is our power, minus 1 over 2. They said expand in ascending powers of t as far as the term in t cube. As far as where? They gave us a limit. They said we should expand it as far as the term in t raised to the power of 3. Whenever you read something like this, as far, you should go far. As where? As the term in t raised to the power of 3, you must end it at t raised to the power of 3. That is what it means, using the binomial theorem. Don't go to t raised to the power of 4. It was not mentioned. They said t raised to the power of 3. That's where you... Why did they tell you to stop at t raised to the power of 3? That is because this kind of binomial is going to give you an infinite series. When I say infinite series, you can never expand this thing fully. Yes, you can only get an approximate solution to this. I'm going to show you something. You look at this. This is raised to the power of 5. In fact, whenever your power is negative or whenever you have a fraction as your power, always know that it is going to give you an infinite series. This is a finite series because we have an ending here. 1, 2, 3, 4, 5, 6 terms, just 6 terms. But in a case whereby your power is negative or your power is a fraction, you can never count the number of terms. And that is why that kind of question, they will always give you a point where you will stop. Yes. So here we have been given a point where we are going to stop, which is t raised to the power of 3. So let's find our expansion using our binomial theorem. According to what I have explained before, we have 1 raised to the power of minus 1 over 2. Your first term will carry your power, while your second term will carry what power? A power of 0 over your 0 factorial. Don't forget that. Plus, now, minus 1 over 2 will have to come to the back. Put it in a bracket. Minus 1 over 2. Then 1. Minus 1 over 2. Subtract 1 away from it. Minus 1. That would be minus 3 over 2. Yes, minus 3 over 2. Then you have your minus 2t raised to the power of 1 over 1 factorial. Plus, again, minus 1 over 2. Now, minus 3 over 2 will have to come to the back again. Minus 3 over 2. Then subtract 1 again from it. Minus 3 over 2 minus 1, that would give minus 5 over 2. Then we have what? Minus 2t raised to the power of... So, raised to the power of... We have 1 here, it will become 2 here. Over 2 factorial. Yeah, we are not done. We are not done. I think we are almost done. Now, go back to the question. They said we should stop at t raised to the power of 3. This one here, t raised to the power of 0. T raised to the power of 1 here. T raised to the power of 2 here. That means we need one more. Yeah. Minus 1 over 2. Minus 3 over 2. Minus 5 over 2. We have to come to the back also. Minus 5 over 2. 1. Now, when you subtract 1 away from here, that would be minus 7 over 2. Minus 2t raised to the power of 3 over 3 factorial. And you are done. That is what they want you to do. Stop here. Yes. So let's simplify our work and we are done. 0 factorial is 1. This one raised to minus 2t raised to the power of 0 is still 1. 1 raised to the power of anything is 1. Yes, take note. You don't have to start stressing on this. 1 raised to all, in fact, all this one, they are 1, 1, 1, 1. Okay, easy. So everything here is 1. Since this one is 1, 1, 1, everything will give us equal to 1. Yes. Okay, let's come here. This one is 1 already. 1 factorial is 1 already. So minus times minus is going to give us plus. You don't rush to write things. Check it out before writing. I knew minus times minus is going to give me plus. 1 over 2 times 2, obviously 2 will cancel 2, that's 1. So what am I left with? I'm left with only t, because I've told you this one is 1 already. I'm left with only t. I'm going to put my t down. Yes. Let's come to the third one. 2 factorial. Okay. This one is 1 already. Minus times minus is what? Plus. Yes. Plus 3 times 1, 3. 2 times 2, 4. So that's 3 over 4. I'm going to write plus here. Yes. 3, numerator we always times numerator, denominator we times denominator. Not 3 times 2 or 1 times 2. No, 3 times 1 is 3. 2 times 2 is 4. That's 3 over 4. Over 4. Let me just put it in a bracket so that it can be clear. This one is 1 already. Now, minus 2t raised to the power of 2. That's 4t squared. 4t squared. Good. Over 2 factorial is 2. I told you before, 2 times 1 is 2. Okay, let's come to the last one. Plus. Now, minus times minus times minus is going to give us minus. I'm putting it in a bracket. 1 times 3, 3. 3 times 5, 15. Over 2 times 2, 4. 4 times 2, 8. Close my bracket. This one is 1 already. Now, minus 2t raised to the power of 3. That would give me minus 8t raised to the power of 3. Now, over 3 factorial is 3 times 2, 6. Now, let's break it down. That's 1 plus t. Now, 4 can cancel this 4, of course. So that's 3t squared over 2 plus 3t squared over 2. This is plus. Okay, this one also. Minus times minus is plus. So it's 2 plus. 8 can even cancel 8. So that's 15t raised to the power of 3 over 6. You are done. That's all. Easy. Easy, right? Yes. So you can, let me give you a question. You can actually play with that. 1 over 4 minus x squared. Yeah, find the expansion of this up to the term as far as the term in s raised to the power of 3. Just the way you have this, t raised to the power of 3. Yeah, you get that also. Okay, so I have come to the end of my lectures on binomial, and I want to believe you understand everything on binomial now. Yes, so you can do well to go back to the video, rewatch, and of course it would stick to your memory. Solve as many questions as you can and you are good to go. All right, so if you like this video, if you enjoyed this video, do well to like the video now. Yes, like the video, click on the like button now, and also click on the subscribe button, because I would be uploading a new video. I'll be making a new video soon, so you can get notified. If you don't subscribe, you might not get notified and you might miss out on my next video. So you do well to like and subscribe, also share. Thank you.